All right. And you will have some problems like these in our homework again tonight, just to practice them a little bit more so you guys can get comfortable with it. So for 11, well, for both of these, 11 and 13, they give you the same points. And then, so for 11, they want you to find the max and min if this is our function. And then 13, this is the function. Alright. So for each of these, all we're doing is taking those coordinates, putting them in for the values, and then saying which has the biggest output and which has the smallest output. So I'm using these same points for both problems. And so the function is 3x plus 2y, and we want to know what the function equals for this one. You found out what you did wrong?
Yeah, I just wrote the function wrong.
Okay, does someone else still want 11? No? Okay, then I'll change it to 13. We're not doing this one. We'll do 13. So negative 2x minus y. So again, it's possible just misconstrue some numbers, something like that. We're putting these values in. So negative 2 times negative 1 minus 3. So that's negative, or that'll be positive 2 minus 3, so negative 1. Then negative 2 times 3 minus 5, so negative 11. Negative 2 times 4 minus negative 1. I mean negative 8 plus 1, so negative 7. And then negative 2 times a negative 1 minus 2, negative 4. So the largest one is actually this negative 1, and then minimum. That was for 13. And then 17 is one that you actually have to go ahead and graph. I'll show you guys that one. Hopefully you guys figured out where you went wrong on that one, if that was the case. All right, so we need graph paper for 17. Those, but oh, I should use regular graph paper. Let me slice them over. Oh my gosh, go away.
You're mean.
Hey.
Why? You're reading this class. I'm stuck with Kinsey.
Nick, you're wonderful.
Like 360 just like Angie left home, so I got like 2 minutes. And it's just me. Wait, we didn't do something.
No,
No.
unless you want to.
I mean, I'm free. I
You'll
mean,
dance?
no. Okay. I just don't have to do anything.
Okay, So guys, sorry.
Grandpa's,
Longer
and probably
than it
eat dinner at his house.
all right. So we have to graph these three inequalities, guys, especially if you didn't finish the homework, I look here. So starting at 1 and then go up 2 over 1. So I'm graphing this line. The first one here. Now, its y is less than this, so I'd be shading underneath. So I'd be shading down here. So I have to kind of just remember that. If it helps to like, oh, and it should be a solid line. If it helps to just like, kind of just draw yourself a little sketch here to remind me I'm coloring underneath. The 1 to 3, y is from 1 to 3, y equals the flat line. So from 1 to 3, I'm going to draw lines here. And again, this one would be in between. And then finally, the next one starts at 6 and goes negative 0.5, so negative half. So down 1 over 2. I wouldn't give you a slope as a decimal. I wouldn't go down half and over 1. So then this is our other one. And this one's less than. So where it shades all three parts would be like this little trapezoid here. All three parts are in this little section here. So what I have to do from that is I have to grab the coordinate points of those corners. So there should be 4 coordinate points there. So 0, 1, 1, 3, and then 10, 1, and then also it looks like 6, is that 6, 3? And that's going to go into the equation that we have, that they gave us, which I don't know, is 3x plus y. And we have to test that again and again and again and see where the max and min is. So I'm putting that in. Q1. So this is the max, and this is the min. So again, we'll be using this idea today in our notes. So kind of as our warm-up questions, and these may be a little bit different with you guys today. I'm going to actually ask that you go into Schoology, so hopefully you brought a laptop. I asked you guys go into Schoology, and there is a daily question in there, like an attendance question. I use it for my students at home. I wanted you guys to do that as our warm-up here. So if you guys could go into Schoology, there should be a daily attendance in there, yeah. This morning, the school should be a negative half. You were going down, so you went down in half and over one, and then you went down a full. I instead of call this negative half. I wouldn't give you a decimal as a small. Your line isn't shallow enough. So guys, I'm asking you guys go into Schoology, please. So everyone should get laptop. Otherwise, if you, for some reason, don't have your laptop, I guess the phone would probably work. And there should be like a daily attendance question in Algebra 2. And it might even come up on the right side of your Schoology. I'm going to show you where it show up. And I thought we could do this as our warm-up, just so I can see where you guys are at on this. So in Algebra 2, there's going to be like a little puzzle piece that's going to come up on the side over here, the daily attendance quiz on the right. guys can just click on that. You guys can go in there and do that. So when you're virtual, this is something I need you guys to do, and I thought we could do it as well. It should be on your own. I'm asking you guys, I believe, to find a maximum point. See, it's a multiple choice question. It gives me a chance, you might get scratch paper, it gives me a chance to know, you guys know what I'm talking about when it comes to what we talked about last lesson. A quick check-in here. Can I just ask that you all do that, please?
Zero over zero.
Should be on your own. So far, everyone in here has got it right. No big pressure. It's not like an actual quiz. It's just you doing a quick check. We'll come around with our notes for today. You're gonna notice our notes for today are short, because there's only like one big example we're gonna do.
Oh, thank you.
Yeah. Yeah. Okay, so I want to show you guys how this actually works with the kind of a real life scenario, like a real life scenario. What is this?
Scenario.
Scenario.
That's what we say in Sheboygan.
Sheboygan.
Snowye.
So we'll talk about this. Oh, so real quick, let me talk a little bit with you guys about the end of the chapter. So we have today's notes and we have tomorrow's notes. Then I plan on reviewing and testing. So I'm thinking we're testing as soon as Thursday in this class. And again, the idea that we see each other every single day, that we just have to test more often, because actually the end of the month is the end of the semester, which is kind of crazy. So end of October
is the end of semester one, so that's when we have like a final exam in here for the first semester of geometry. So my plan is to test on Thursday in here. So if you're someone who likes to kind of plan that ahead, if you're struggling with any of this, or you do together.
Tuesday, 2 tests on Wednesday, and a test on Thursday. Go me. Why?
Okay. So, but that also means if you're still thinking about retaking our most recent test, you'd want to be coming in for corrections and a retake sooner rather than later. But I don't think there's many of you that needed to do that, but if that was something you were thinking of, I don't want you to wait until the end. We probably will still get another couple tests in after that, 1 or 2, depending on how things go, so, and how long the chapter's out. So, for 10-5 here today.
All right.
So again, we're doing this one big problem. If you notice, this is just one giant example. It's a really big problem. If you'll notice, our homework is there's only 2 questions off of this stuff because the problem is long. And then some of the other homework will be review problems, like from last time. So just a heads up on that. So it says a workout company charges $3.50 per child to use the facility, $8 per adult. So like if you go to the YMCA or something like that, that's the charge per child or the adult. Now, this is almost like even more so. There will be at most 40 kids working out at one time. So COVID regulations here, and this actually was before COVID, but now it sounds more applicable. They limit to how many people can be in the workout facility at one time. And no more than 16 adults, because adults are bigger. The total people must be less than 50, so we have that limit. And again, really bizarre that I made this last year, and now like the 50 is like that magic number of like, you're not supposed to have more than 50, because 50 apparently spreads COVID. So, sorry, I probably shouldn't have that.
2 could even spread it.
Oh, right, I know, 50 is like that number they use all the time.
49.
So, 49 is safe.
Oh, that one guy.
I
That one
know,
guy that comes
the
in.
one extra guy with COVID. Okay, so, it says, we want to write an inequality to limit the number of children. So we want to write an inequality that talks about the number of children that can be in our facility. So how would we write that as an inequality? From what to what?
Less than or equal to.
Which one? Through children? How many?
Less than or equal to.
So children want to be less than or equal to 40. Children are less than or equal to 40. Now, I'm going to put an other end on that. I'm going to, so when we talk about, when we graph these, we talk about a feasible region. What makes sense for children? Can we have negative children? No, that doesn't really make sense, and I don't want to talk about like a situation where negative children make sense, because that sounds scary. But, so what would be the smallest number of children we could have? Or there could be no children, or 1 child would be the smallest. So we're going to go from 0 to 40. Does that make sense?
Yeah.
So keeping that as a feasible region. So we could have no children. Like if you go during the day to the YMCA, maybe there's no kids there because they're in school or whatever.
They're at work.
Yeah, work. They're hard at work on their jobs. Child labor. All right, so 0 to 40, that's the feasible region for children at this facility. How about adults? What would our feasible region be then?
Less than 16.
We want to be less than 16 adults. Remember, we said adults are bigger. So adults,
Can I even? Oh wait.
we'll worry about that other part of it in a second. But then we also can't have negative adults, so we're going to go from 0 to 16, right?
Negative adults.
Yes.
Would you leave the library because this says no more than 16?
Oh yeah, that's probably a good point. We probably want that to be no more than 16. So 16 is okay. 16 is okay. The same thing at most 40. Yeah, no, it's a good question though. Like that quick discrepancy, like the 40th person walks in and like, we have to make sure, I don't know. So, it says, the next part, the less than 50 maybe, then we need to talk about that. So it says, the total people must be less than 50. Writing an inequality for the total number of people. So, I don't want to add a third variable to this. So I want to somehow use the number of children and the number of adults to talk about being 50 or less. Does anyone have an idea on how to write a third equation only using those two variables in the 50? I want the number of total people to be under 50, but I don't want to add a new variable in. Any suggestions on how to do that? So give me some, yeah, go ahead.
Combine them,
Combine them, how do you combine them?
AC.
That'd be times, right?
Oh, yeah.
A plus C, right? So the number of children and the number of adults together, adding them together, needs to be what? Less than 50. Does that make sense? A plus C, the number of adults and children together needs to be less than 50. Otherwise, COVID.
Otherwise, the fire alarm will go off and be like,
Right. And they did have like fire code before, like there was, you probably walked into places before, like especially like an elevator, I think you see it most often, where it says like maximum people, like 8 or something, or weight, then they start counting the weights of everyone in the elevator, and that's awkward. So, so when I was in high school, we would, I loved, physics was my favorite class in high school, and I thought I was gonna be a physics teacher, but then I took physics in college and decided that was not gonna happen. So, but in high school, I loved physics and I loved roller coasters. And we went to physics day at Great America, where we went and like learned about like all the physics behind the roller coasters. And my high school physics teacher, he came and the wrestling coach was on as a chaperone, and so was another man, like a big guy, or maybe 2 more big guys that were our chaperones. And they go down the giant drop, the one where it just like drops you straight down. And the 4 guys are standing there to get on the ride. She had like the 4 big teachers. And all of a sudden they look and they're like, maybe we should move 1 or 2 of you away. And it was kind of like that eyeball thing where they were just kind of like, you guys look a little too heavy for that car. And so they like separated them. But like, it was totally like, what if they had not moved them? Like, would the brakes have failed like on the giant drop? So then after that, I was kind of like, wait a minute, like, can you like check my weight and make sure that like, the brakes, because the giant drop is the one where literally if the brakes fail, like you're just going to the ground. You're probably fine. Yeah.
Don't they like make you stand on something now?
Maybe they do.
Water parks.
Yeah, I don't know if the giant drop you do.
Well, I don't know how, like, because one time I was at these people went and that car actually stopped even though they had like.
Yeah, because the water park one, your whole family like stands on the thing together, and we're all like trying to figure out how much we all weigh, like in your swimsuit, which only adds to the stress of the situation. So
Your
yeah,
heavy swimsuit.
My mom,
Promote.
right before we went on like a really big water slide thing, she was like, "Did you hear about the kid that got decapitated on the water?"
Well, that totally happened.
Yeah.
That was a real thing. That happened in Kansas City.
The thing went
Yeah.
ugh.
Oh.
Nope.
I actually saw that slide because one of my best friends lives in Kansas City. We drove past it and it was like this huge water slide and the kid died.
Imagine the parents like at the bottom of the slide.
Oh my god, I can't even. And so they had the slide up after the kid died. Like they didn't take the slide down forever. So like we drove past it after the kid was killed. And I'm like, can you imagine being his parents and driving past the slide that like
Yeah.
killed your kids like on your way to work or something every day? Like probably go a different way. But like it's crazy. So yeah.
Yeah, and that was right before we went on this like big water slide. So I was like, Mom.
Right.
So.
Anyways.
Anyway, so 50 pounds, not 50 pounds, 50 people. Okay, we're staying safe. So sorry people online, because we just talked about decapitations, but, so,
Monday morning.
yeah, Monday morning decapitation. All right, so we're gonna graph the feasible region. So we have to put this on a graph. Now, we have to decide what we want to be kind of considered our X and what we want to be our Y. So since we picked it first, I'm probably gonna call children our X coordinate. So I'm gonna put the children across the bottom. Sounds funny. The children are gonna go across the bottom. And then the adults are gonna go up the side. Also straight. Okay, so adults and children. Now, do I need to include the zero, like the negative values? Probably not. So I'm gonna make this like an L-shaped graph. 'Cause I don't need to know about negative adults or negative children. So I'm gonna space this out across the bottom and up the side. I need to go up to 40 children and up to 40 adults. So I don't know if I'm gonna go like 3 spaces over and call it 10. I don't know, it doesn't really make sense.
Let me just delete
Sorry.
that. Okay.
I'm just trying to think about like a good way. I guess that's fine.
3?
I don't know. I did 2 and then it's a short. Yeah, it's probably fine. So, sorry.
Let me
just
erase
erase
that.
it
Well, you could leave those lines there. Sorry. I didn't like the way I had it the last time I did it, but I don't think I like it this way either, so we'll do that. So 40 children, and then up the side, then do the same thing.
Oh.
And 40 adults up the side. Even though we never get up to 40 adults. So we have to go from 0 to 40 children. So that's gonna take us in between here. And I'm not gonna color that all in, because otherwise this whole thing's gonna be colored in like completely. But then 0 to 16 adults. So this is 15 here, so 16 would be like right about there. So this would be the shaded in part. That makes sense so far? We're not quite done yet though. You need to draw one more line. The other line is the combined totals together. So remember that you can't have more than 50 total people. So I have to think about how to graph that line. So I want to figure out how to graph this one. Now, this is the X. That means the adults are the Y. So I want to get the Y alone. So I want to get the A alone. So how do I get A alone?
Subtract C.
Subtract C. So I get A is less than negative C plus 50. So I'm going to begin this at 50 on the y-axis, which is our a-axis. And then I'm going to go down 1 over 1. Oops, why am I calling that M? My B is 50. And then my M is a negative 1. So I have to draw that in, that other line, that makes sure we kind of keep the whole value under 50 to make sure we're not over our 50 limit people. So for our graph, I'm going to go up to 50 on the y-axis or the a-axis. And then I'm just going to go down 1 over 1. So, and it's got to stay under that. So the colored in part is going to be this little pentagon here, I guess. It's a pentagon because it's 5 sides. Even though it doesn't look like a pentagon. And just like, so now the difference between this and yesterday was, or last class, yesterday was Sunday, last class was the idea that we didn't ever have like a real life scenario for this, scenario. we didn't have a real life situation. So now we're talking about, now here's a real situation where let's talk about the feasible region. So we want to pick the coordinates of the corners. Now this might be a little bit difficult in like one or two of these cases. They might not seem exact, so we might have to do a little bit of estimating. So what's one of our corners of our region? What's that? So 0, 0. Zero, zero, probably not a very interesting one because that means no kids and no parents or no adults came. All right, what's another feasible? Yep. I think you want to flip it. 0, 16. Yeah. 0, 16. So when we just go straight up 16, that's our next point. This next one might be a little bit difficult. We know it's at 16, but it's kind of like this way from 35, right? What do you guys want to call it? 32. 32? 34? I think 34 makes sense because if there was 34 children, there could be 16 adults, right? So I'm going to go with 34. Whoops, not 3. 34, 16 again because 34 and 16 would be 50. So that's the most children, most adults that could go in there. The next one was all the way over here. If there's 40 children, how many adults? Would be 10 adults. And then there also could be 40 zeros. Like, all right. So the reason why these problems are tougher is because they don't give us all this information. We have to find all this information, so we have to graph it. We have to get these points off of here. The next part is probably the toughest for a lot of people is we want to write our function for the cost of entry. So we're trying to write the f of x part. Or the f of xy. Now we're talking about f of c is children first. Children and then adults. Go back to the original problem. What do we know about the cost or the amount for each child that comes in? How much do we get for each child that comes in? $350. So I write that as $350A. Or sorry, C. For children, sorry. That's why I like using letters that actually make sense so you catch yourself rather than just X and Y. Plus, how about the adult price? $8. $8, so 8A. So we want to figure out which combination yields a maximum. Which one would give us the most money for our situation? And you might have some guesses right away. Hopefully you'd like throw out 0, 0. That doesn't seem like that would be the one that would give us the most profit. So which ones do you guys want to try? There's probably only a couple that you probably even worry about. What do you think?
40, 10.
40, 10. Whoops, sorry, I put it in the wrong spot. 40, 10, we're gonna check. What is it? You said 34, 16. We'll check those two. We're gonna check and see which combination yields a maximum and then how much does it give us? What would be the amount if that was the case of what came? I'm gonna try each of these now. Will be more obvious than others. This one's not too mysterious. So I get 220 for this top one. But for the bottom one, I get 247. Does that sound right, guys?
Yes.
All right. So the combination that yields a maximum is 34 children with 16 adults. And then how much would be the amount of money collected?
$247.
$247 for them. Okay? Questions? All right, so let me explain what our homework is, and then I thought maybe we could even, if you guys wanted to, we could work outside if it was possible. The only thing is it might be a little windy, I'm worried about that, but let me explain the homework. So there's graph paper here. The top graphs are probably better for the review. The review is in the back of the book, 882, and I have those pages like set out for you guys, just 7 and 8. That's the ones where you're graphing it and checking is it a max or a min. So 7 and 8, and that's on page 882, but I took a picture of just that part of the page. And then the next two are the two where you're gonna actually have to write the equation, write the inequality. So those are gonna be longer questions. And I'd be glad to help you with them, and I wanna give you guys time to work on them. But those two will take a little bit longer, and you might want the graphs on the bottom that are like more like open-ended, that you can choose to graph them a little bit differently. So that makes it, so it's only 4 questions, but it might not be the easiest 4 questions, so I'm glad to help if you're stuck on something. So I really suggest trying to get it done in class so that I can help you if needed. Does that sound okay? All right, let me stop this.